In this how to design data problem, the type comment is going to end up with a one of, but not all of the subclasses are going to be single distinct values. So this is what's going to be called an itemization, and it'll be the most complex form of data that we see this week. This is the problem in Countdown Starter. So what we're supposed to do here is design a data definition to represent the current state of a New Year's Eve countdown. So this is something like the countdown ball in Times Square. And we're asked to design a data definition for that. As always, when we design a data definition, the first thing is to clearly identify the information in the problem domain that we're trying to represent. And in this case, the problem statement makes that very clear to us. In particular, it makes it clear that the information falls into one of three categories. The countdown hasn't started, it's from 10 to 1 seconds before midnight, or it's complete. The previous problem we saw, the letter grade problem, also had three categories. But here the categories are different. This first one is kind of distinct. The countdown hasn't started, that's a clear, distinct state. But in this second category, there's not a single distinct value there. There's 10, 9, 8, all the way to 1. So there's a number of different values there. And then in the third category, again, there's a distinct state there. The countdown is complete. So this isn't going to be an enumeration. This is going to be what's called an itemization, because there are two or more subclasses, at least one of which is not a single distinct value. This center one is not a single distinct value. So that's going to be an itemization. And again, after this video is over, I encourage you to go to the Design Recipes page, go to the How to Design Data page. This table would remind you that itemization is what you need to use in a case like this, and you can go and read about the itemizations. Do that carefully after this video is over. I'll work through the problem now. So let's see, we start with the type comment as always. So we'll say that countdown is one of, and there's three subclasses. And now we have to decide for each subclass how we'll represent that, what data will represent that. Well, let's see, if the countdown hasn't yet started, that's kind of a distinct state. So we could use any piece of atomic distinct data to represent that. Let's just use false. Okay, we'll use the Boolean value false to represent that the countdown hasn't yet started. Now in the second subclass, let's just say that that'll be a natural number from 1 to 10 inclusive. And in the third case, we also need a distinct value there. And we'll just use the string in this case, complete. So now we've got three distinct subclasses that correspond to the three distinct kinds of information that need to be represented. And we'll do an interpretation here. And I'll use multiple lines for this interpretation. I'll say false means countdown has not yet started. Natural 1 to 10 means countdown is running and how many seconds left. And complete means countdown is over. Okay? And if you want to, you can indulge your inner Virgo and make these line up nicely. And if you don't want to, you don't have to. There's the type comment and the interpretation. Now we need some examples. So we might say, define countdown 1 is, now I'll put a false here. It's an atomic distinct, so in some sense you might find that that example is not particularly illustrative. But maybe I'll have countdown 2 is 10, and I could put a comment here if I want, just started running. Define countdown 3, almost over, and define countdown 4, complete. And that one's clear.